Hello. So we are going to discuss question 2 and question 7 for the stochastic calculus for financial economics CBT. So for question 2, cooperative food stock has a current price of $35. Its volatility is 20%. So stock price is 35, volatility is 20%. And then the dividend is 2%, and the risk-free interest rate is 6%. So risk-free interest rate is 6%, and we are given the stock price at the end of every month. The random numbers are these, and we are asked to find a 48-month Asian average strike call option using arithmetic average. So from this random number, we can actually generate the simulated stock price with this formula. So the stock price will be initial stock price multiply with ER minus delta minus sigma square over 2 and multiply with the T minus T and plus with multiply with T and plus with sigma square root of T and the Z value. So from the random number, we can actually get the Z score. And from this, after we get the Z score, then we can find out what is the ST using this formula. So after we get the simulated stock price, we can get the arithmetic average and use the arithmetic average to be our strike price. So our arithmetic average will be we sum up all the stock price and we divided it by 48 because there are 48 simulated stock price. So basically we find the average of all these stock price. And we get the average is 59.957919999. So we will use this as our strike price, and at time 48 month, our simulated stock price is 65.2489. So our expected payoff will be since this is a call, so our payoff will be ST minus K. So our expected ST will be the G50, which is stock price at time 48, minus our strike price, which is the average, the arithmetic average. So this is our expected payoff, 5.290941. And then our call price will be the expected payoff discounted to times 0. And for number 2, we are asked to find the 36 strike, so means that our K is 36, and then the geometric average price. So our ST will be the geometric average of all the simulated stock price. So geometric means that we will multiply all this and we power 1 over 48. So basically it's this 59.2114908. So our strike price here will be 36, and our stock price, we will use this G48. And since this is a put is K minus ST, so our expected payoff will be 36 minus G48. which is a negative value, so our expected payoff will take 0 instead. And our put price will be discounted the expected payoff, so 0 discount back to times 0 is still 0. So this is question 2. And for question 7, a London-based fashion designer is expecting to receive 1,000 million yen from a Japanese company as payment for goods sold in 1 year. So the company decided to hedge its currency risk by purchasing an option that grants the right to exchange yen for pounds at a rate of 0.0055 pound per yen. So we need to calculate the cost of hedging using a 12-period binomial tree with pound denominated and also yen denominated. So for pound denominated, we will need to buy a put, because for pound denominated, so now I am a British, so I would receive this much of yen at the end of 1 year. So this will be my underlying asset. So I will need to sell this asset to exchange for pound. So because my domestic currency is pound now, so I need to sell this yen to get pound. So the right to sell, which is put, so I will need to buy a put. So to buy a put, my current X0 is my current exchange rate, which is 0.005 pound per yen. And K is my strike, which is 0.0055 pound per yen. And the sigma is 0.08 given by the question. And the risk-free rate, since I'm pound denominated now, so my risk-free rate will be 0.035. And my foreign risk-free rate will be the yen risk-free rate, so it's 0.055. And the H will be 1/12 because it's per month. So to calculate this put price, we will need to calculate the expected payoff and multiply with basically this is the put is 1 year, so I will have 12 months. This is a 12-month period binomial tree. So for S0, for every S0, I will multiply with a U and a D. So until 12 period, then I will have S0 UD and S0 D square and so on. So up until 12 period, I should have S0 U12 and S0 U11D and S0 U10D square and until S0 D power 12. So this is the S0. In this case, is the X0. So X0 times U power 12 and times D power 0. And this will be X0 times U power 11 and D power 1 and so on, which is this part. So this will be our currency rate at time 1 using the binomial tree. And since this is a put, we will have K minus ST. So our K is 0.0055. If this is large, if ST is larger than K, then we will just put 0. If not, then we will use K minus ST. Then we will get this payoff at every node. After that, we will have our probability. So the probability for each node then will be u power 12 times 1, p minus p power 12 and multiply with 1 minus p power 0. And this will be p power 11 multiply with 1 minus p power 1 and so on. So this is the probability for each of these. But then for every node, we not only have one possible way to reach that node. So for this one, we will only have one possible value because one possible way to reach this u power 12, because the only way is we will have 12 times u. Means that we will go to u and go to u and go to u again and go to u up until I reach here. So there is only one possible way to reach this. But for U11D, then we might have U. We might have 11U and 1D, or we also can have 10U and 1D and 1U and so on. So there will be many possible ways to reach this U11D. So the how many possible way here? Then will be 12 factorial divided by, there's 11U, so 11 factorial, and 1D, so 1 factorial. So we will get this. So means that 12 factorial divided by 11 factorial and divided by 1 factorial. So for this one, then we will use, for this U10 and D2, then we will have 12 factorial divided by 10 factorial and 2 factorial. So we will get 66 and so on. And we multiply the probability with the factorial, then we will find that, then we will see how much is the probability to reach each node. And you can see that the total of this, then we get 1. So this is correct. And then we will need to use the payoff to multiply with the probability. So we will have payoff multiply with probability, and this will be payoff multiply with probability and so on. And at the end, we will add up the payoff times probability. Then this will be our expected payoff at the end of year 1. So our put price will be discounted payoff, discounted expected payoff at time 1, discount to time 0. Then will be our put price. And the put price, the put we buy here is for 1 yen. So we will have this much of yen at the end of 1 year. So we need to multiply the put price with this. So we multiply the put price with the value of yen we were going to get after 1 year. So means that we will need to buy this much of the put. So the cost of this hedging will be 59216.2928. And for yen denominated, we will buy a call, because now I am a Japanese, assume that I am a Japanese, and I will get this much of my domestic currency at the end of 1 year, so I can use it to buy the pound. So the pound is my underlying asset now, so I need to buy the asset. So I will need a right to buy, so I need to buy a call. So when I buy a call, then now my currency will be yen denominated. So means that my current exchange rate is 0.005 pound per yen. So if now I'm yen denominated, so means that I will need to know how much to buy a pound, how much it costs to buy a pound. So I need to 1 over 0.005. So this is 200. And for strike price, we will also do the same thing. We will convert the pound per yen to yen per pound. So we will get this. And now our R will be the yen denominated risk-free rate. So it's 0.055. And our foreign risk-free rate will be 0.035. And now we will find the call price. So we do the same thing. So there are 12 periods. So this is 12 until 0 and 0 to 12. And for X, we also do the same thing. We will take the X0, multiply with the U power 12 and D power 0 and so on. So for every U and D, we will do the same thing. And then since this is a call, so we will have ST minus K. And this is our payoff. And the probability, we do the same thing. We will have P power 12 and 1 minus P power 0. And this will be P power 11 and 1 minus P power 1. And we also have the factorial, and we multiply the probability with factorial. Then we multiply the payoff with the probability, and we sum up. So this is our expected payoff at time 1 for this call. So our call price will be discounted expected payoff at time 1 to time 0. And we will need to buy this much. We will need to buy this much of the call because because now we will have this much of yen at the end of 1 year. So we can use the yen. So for each call, we will need to pay a maximum of 181.8182 in order to exchange for a pound. So because this is our strike price, so we estimated that we will need to pay this much of money to exchange for a pound. So it means that if we have this much of yen, then we can buy then we can buy around 550,000 call to exchange for pound after 1 year. So we will buy this much of call. So means that we multiply this much of call with the call price. So we multiply this much of call with the call price. So our answer will be 1184325.8.6. And we also can see that this is basically the put price in pound converted to yen using the current exchange rate. So means that this multiply the current exchange rate. No, this we will have the current exchange rate is 0.005 exchange with 1 yen. So when we have 59216 59216.2928 is equals to how many yen? Then we will need to 1 divided by 0.005 multiplied with 59216.2928. So we can see that the put price, when I convert the pound into yen, basically I will get the same price with the call price. So this is for part A. And for part B, to calculate the price of the option by conducting a Monte Carlo simulation of 100,000 iterations using Microsoft Excel. So now we generate 100,000 random number. So we will have, so we can see here there's 100,000 random number. Oh, so start from here. Okay, so so we convert the random number into z-score, and then we can find the exchange rate. So same thing, the exchange rate then will be x0 multiplied with ER minus delta minus sigma square over 2 times T plus sigma square root T times the Z. So using this formula, we can get the exchange rate here. And then for part B, I choose to do it for put option. So means that I assume pound denominated. So my risk-free rate will be the pound denominated, and my foreign risk-free rate will be the yen denominated risk-free rate. And my payoff will be K minus ST, since this is a put. So I have K minus ST and compare with whether which is larger, compare with 0. So I'll get my payoff is this. So my expected payoff is the sum of is the average of this. And my put price will be discounted expected payoff. And then I put price, I need to multiply with this value, because I will need to buy for this much of yen to hedge this much of yen after 1 year. So I get the answer is 59021.4985, which is quite close to the put price here. So that's all for question 2 and question 7. Thank you.